Having a drive-ready light is one of those simple things that just makes your life easier. Why? Well, when the CNC uses RS-45 to communicate with the drive, for example, the CNC relies on status messages from the drive to report issues or alarms. If the drive isn't ready, then the CNC gets no replies and gives you an error. So the drive-ready light tells you when it's okay to turn the Altmill on. Now, in truth, that's really not such a big deal, because as you can see, the drive is ready just a couple seconds after turning it on. But what is a big deal is knowing when a drive is fully powered down and safe to work on. As you can see, it takes a while for the drive to bleed off all the energy stored in the large electrolytic capacitors, and you don't want to be fooling around with the drive until the voltages are down to safe levels. But does the drive ready signal actually tell you it's safe to work on the drive? Well, let's take a look. The free GSoft 2 app allows us to monitor what's going on inside the drive. I have it set up to monitor the bus voltage and digital outputs. I'll start that up and power up the drive. And we see the bus voltage ramp up on the graph and the actual value here. There's an implied decimal place, so that's 300 volts, not 3000. Turn the drive off, and we see the slow decay of the bus voltage. We can also watch the digital output I'm using for the drive ready signal, and while it's too small to see over here on the graph, you can see its value here. Let's let the bus voltage go all the way down. Great. Okay, stop that. Let's scroll the cursor till we see the digital output go away. The 16 is because it's the 5th bit in this digital word, and I have all the other bits disabled. We see the bus voltage only gets down to around 180 volts before turning off the drive ready signal. Now, is that safe enough to work on the drive? Well, no. Most folks will tell you safe is well below 50 volts DC. So while it's not a drive is ready to work on indicator, it does serve as a reminder that the high voltage does linger, and given another 10 seconds or so, it will be safe. I put links to the free GSoft 2 app and some video tutorials in the description below if you want to learn how to use it. Again, it's totally free. Okay, now that we understand what's going on, let's do it. The good news is the GS20 series drives make it super easy to add a drive-ready indicator without any extra option modules or software or power supplies or other doodads you have to buy. It's all built into the base drive configuration. All we need to do is set one parameter to tell the drive which output to use for the drive ready signal and wire it up. Now, if you just need a punch list, here it is. Stop the video, take a screenshot, and go do it. Now, if you want to understand why we did it that way and pick up some hints and tricks along the way, well, stick around. We'll quickly walk through all of it, and as a bonus, I'll show you an easy way to debug the digital outputs if things don't work out the way you expect using that free GSoft 2 drive configuration and diagnostics app. Here we go. These are the parameters used to configure all of the outputs on the drive. We'll be using output 2 for this project. I used output 1 for my automatic dust collection control. Check out that video to learn how to do that. Now, I could go look up the parameter values in the manual and enter them into the drive's keypad, but since I have GSoft 2 running, I'll just go to the parameter page, select the digital inputs and outputs, scroll down to parameter 217, and look, all the options are already there. I just pick the one I want and hit enter to lock it in. That takes effect immediately. We don't have to power cycle the drive or do anything special. Great, the drive is configured. Let's wire it up. The digital outputs are simple transistor switches. I love that the GS20 drive's outputs are optically coupled so the drive is protected if something goes wrong with the external wiring. And they're very flexible. You can wire them as syncing or sourcing outputs. Now, that confuses a lot of folks, so let's take a minute to understand that. We'll wire digital output 2 to the drive indicator like this. So when the output's enabled, current will flow to the indicator. That's called a syncing output. The load is pulling or sinking current from the drive. What voltage should we use? The GS20 digital outputs can handle up to 48 volts DC and 50 milliamps, so we have lots of options. The easiest is to use the built-in 24 volt DC supply that's already on the terminal block. So we'll just connect them like this. The only issue with syncing outputs is all of the digital outputs use the same digital output common, so they'll have to use the same 24 volt supply, and that supply is limited to 100 milliamps. The LED indicator I'm using draws 14 milliamps max, so we're in great shape. We could also wire digital output to like this, where the indicator is supplying or sourcing current to the drive. We call this a sourcing output. When a transistor switch is active, it provides a path to ground and the LED lights up. And again, since the terminal strip has the built-in 24-volt DC, we could use that instead of buying an external power supply. So which is better? That's personal preference. The limitation with the sourcing setup is you're always running power to the indicator and relying on switching the ground path to activate the indicator. It's not a big deal, it's just a little harder to debug than syncing outputs where you simply look for the absence or presence of power at the indicator. The advantage of a sourcing output is the digital output common is now connected to the supply common and the other digital output like this, which means you can run the other digital output from a different supply voltage, which could be handy if you need to control a 5 or 12 volt device, for example, or anything up to 48 volts. All of our stuff runs on 24 volts, so we'll stick with the easier syncing wiring. So we just need to jumper these two terminals and run a pair of wires out to the indicator on the drive's power switch. I'm using an industrial switch from Automation Direct for this. You can use any switch and indicator you want. This switch comes with an integral 24 volt LED light. You just connect the digital output to one side and return to the other. The polarity doesn't matter. The switch comes with one of these green terminal blocks, so I did have to add a second one for the other power wire. The indicator wires go to this terminal block and land here on the drive's terminal strip, which is clearly identified on the diagram inside the drive's door. The 24 volts in its common are here. So all we need to do is connect the 24 volts to the digital output common and these two to the switch's indicator light. And the thing I really like about the GS20 drives is if you use ferrules on your wires, you just shove them into the clamping connectors. Super easy. To remove, just press the little release button next to the terminal and pull. It's so easy and super secure, and you never have to worry about screws coming loose. Now when we apply power to the drive, the indicator light lights up once the drive is operational. And even more important, turn the drive off. And wait. Keep waiting. There it is. Now we know that bus voltage is more than half the way down. Perfect. Now what if the light doesn't work the way you expect? What would you do? Well, the GSoft2 scope function shows you all of the I/O at a glance. This is output 2, and sure enough I see it's active, so the indicator light should be on. If I turn that function off, yep, light goes away. Re-enable it, and it's back on. The drive is telling us that it is activating the output, so the issue is probably with the wiring or a bad bulb. GSoft2 makes debugging super easy, so I really want to encourage you to take a few minutes to download it and learn how to use it. Again, it's totally free. Links to the software and the tutorial videos are in the description below.